One, two, three. Hi, everyone. Welcome to our third and last live stream of the week celebrating National Coding Week. My name is Jonathan Trunk, and I'm the head of community. And joining me is Michelle McSweeney, our data science domain manager at Codecademy. Today, Michelle is going to walk you through one of our most popular portfolio projects that will have you analyzing 538 NBA data. Let us know what your favorite NBA team is in the chat. We're also making this project free for a week so y'all can follow along. This is our last live stream for National Coding Week. So if you missed our previous two, here's a quick recap. In our first, we walked you through how to build a technical portfolio using HTML and CSS. And then for our second, we showed you how to make it interactive using JavaScript. If you missed them, definitely go back and watch. Before I hand it off to Michelle, two things. First, don't forget that we have 50% off of our pro subscription for a limited time. We'll drop the link in the chat right now. Second, I wanted to let everyone know how talented and accomplished our instructor Michelle is. So a few fun facts. First, Michelle is a former park ranger, yoga instructor, and palm reader. She's also a linguist, data scientist, and educator who, as I said before, is a data science domain manager at Codecademy. Second, she has a PhD in linguistics and teaches data analysis and visualization at the CUNY Graduate Center. And lastly, if those things weren't enough, she's the author of not one, not two, but three books. The first is called The Pragmatics of Text Messaging, which is already out. The second is called OK, which comes out in January. And the third is called Data, which will drop in 2024. All right, so enough of me talking. Michelle, please take it away.
Awesome. Thank you so much for that very generous intro. So first off, I want to remind you to ask questions in the chat. We're going to go through this project, and I might not touch on everything that you are curious about or everything that you're unclear about. So be sure to drop your messages, drop your questions in the chat. And our extremely talented curriculum developers, Ada, Eva, and Lucas will all be there to answer your questions and surface anything that I should really go back and review a little bit. The project that we're taking you through today is normally part of our paid pro membership, but we're making it free for a limited time so that you can follow along. Sign up via the link in the YouTube description. The first two live streams this week for National Coding Week took you through how to build a portfolio. The purpose of today's live stream is to walk you through making something to put in that portfolio, to show off all the cool things that you've learned how to do by working through your Codecademy content, by working through your career paths. Okay. I'm going to take you through this project. This project, just as a preface, is exploratory. So when you're building out your portfolio, this would be something that would show that you have basic skills, but including it in your portfolio, you probably include it with some sort of analysis. All right. So without further ado, I am going to start sharing my screen. And here we go. And NBA trends. So I hope everybody has dropped the name of your favorite NBA team into the chat. I will be completely honest that I don't really follow the NBA that closely, but I do follow statistics that closely. And this is a really cool project that addresses both sides of it. Okay, so we are going to work with some data from the National Basketball Association. And what we're doing here is we're exploring possible associations. I'm going to pause right there. What on earth is an association, right? An association just means that two variables might be related to each other, that one might, influence the other. We're not going to explore whether, we won't be able to defend whether they're related. And we aren't going to explore how they influence each other, the directionality of that or anything along those lines. We're just trying to figure out, should we explore those things? Which, as you might know, is a pretty big question all on its own. Which variables should I be interested in? Answering that question is like 70% of every project. Okay, so this data originally came from the NBA. And it comes from 538. So 538 is it's like a a news organization, let's say, that does a lot of statistical analysis on politics, sports, and just general interest topics. They're really mostly known for their politics and sports. You can read more about the data from the link in the project, but we have pre-cleaned the version that you're looking at to just look at 5 teams. We did that basically so it'll run faster. You don't want to look at all of the teams because it'll run very slowly unless you're building this out for your own portfolio project. Okay, we're going to create a few charts. We're going to create a few tables, and we're going to talk about why we're running each statistic that we are. Without further ado, let's get started. We'll go through the other things. Quick little note. If you have Jupyter notebooks installed on your computer, feel free to do this off platform. It makes it a little bit easier to export it and then host it somewhere where you might drive traffic to your project. Okay. And at the end, we'll talk about different ways that you can present this work for a portfolio. Okay. So the first thing that we are going to do is talk about these packages that we have installed. So we are importing NumPy, and we're giving it this alias NP. We're using NP, 1, because it's convention, and 2, because I am extremely lazy. I don't want to type NumPy every time. I'm just going to type NP every time. We've also used pandas and given it the alias PD because it's shorter and easier. These two go together a lot. And the real purpose of these two packages is to let you work with a CSV or other data set as what's called a data frame. Data frames have a few special properties that you can learn about in the course. I'm not going to dive into here because it'll take us too far afield. Okay. The next thing that we're going to import is from SciPy stats. We're going to use Pearson's R and the chi-squared contingency. What are those? Well, we know in advance what 2 statistical tests we're going to want to run. That's what these are. We'll cover it a little bit more depth and some of those assumptions when we get down to it. We're going to make plots with a package called matplotlib, again, given it a short alias, and we're going to use Seaborn to make those plots much prettier. Okay, so the first thing that we're going to do that I need to explain a little bit is import Codecademy lib3. This is something that if you're working externally, you won't need to do. This is a specific package for working within our platform to make sure that all of the plots render nicely, to make sure that the data frames render nicely, not something that you actually need to worry about. This set print options is really useful everywhere. So, pro tip, set print options lets you see your entire table however you want to see it, right? So you can see the whole thing. You can say, don't give me more than 2 decimal places. You don't need to show me the index, those kinds of things. It saves visual space and makes it a little bit easier to work with. So that's what's going on here. All right, now let's get to actually doing things. The first thing that we are doing is loading in our NBA games CSV. Now, this might be stored in a folder on your computer. If you're doing it off platform, you don't need this part. This just says, hey, move up 1 folder and find this CSV file. What that looks like for us is this CSV is hiding in this same folder with our script file. I can actually open it, take a look at it. Right, I'm going to close that. And you can see how this is organized. Really, really hard to read as this like giant list. So that's why we're going to read it as a data frame. Okay, so I'm going to do from pandas.read CSV and then tell it what to read. Okay, I'm going to give it the name NBA. Now, and this is all preloaded for you, we're going to subset the data into 2 seasons. We're going to go season 2010 and season 2014. So I want to filter on this year. So I know already that there's a year in my data frame. And I'm like, okay, all of the year ID should be the year. I just want the 2010 season. So I've done it 2 different ways to point out one of the most confusing things about working in pandas. So when you are subsetting this, you can use what's called bracket notation or dot notation. And it's going to call the column just the exact same way. Okay, so when I was first learning to program, I was like, why do I keep seeing things these 2 different ways? This is bracket notation and this is dot notation. So I've made a brand new data frame and I've called it NBA 2010. I've taken the old NBA data frame and using that to make a big hug. And then I'm saying, give me just where the year is equal to 2010. So this is basically saying where the year is equal to 2010, and then give me the rest of the data frame. Here, it's saying the exact same thing. It's just calling the name of that column a little bit differently. Okay, so we've subsetted our data, and now we're going to inspect it to make sure that it's giving us what we're expecting. Okay, so I'm going to say print NBA 2010, just the head of it, just the first 5 rows. So like the very, very beginning. Now I'm going to make this really small so that we can inspect this together. This is probably the most important part of any project you're ever going to do. Okay, we're going to go through these variables. So we have the game ID, which looks to me like it's the year, the month, the day, and then, you know, who's playing or where it's being played. Okay, so this looks like a unique identifier. I have the year that it was played, the franchise ID, this looks like the Celtics, who they were playing against, the Cavaliers, the location. So for the Celtics, this is away. That's an important note. I'm looking at this and I'm saying, okay, so the creators of this data set are framing it from this column. Like conceptually, they're building up a mental model about this data set that like the franchise ID is what we're stating everything in relation to. So game location is in relation to the Celtics. Is it playoffs? That's just a yes or a no, a 0 or a 1. How many points? So points refers to the Celtics. Opponent points refers to the Cavaliers. Game result. Obviously, this has to refer to one and only one team. So it refers to the Celtics. The forecast. So I was like, what is the forecast? The forecast is something that was created by FiveThirtyEight, and it's their own particular variety of forecasting who's going to win that game. It takes into account the ELO or ELO score, as well as whether it's home or away, with the location. Okay, so we're going to look at that forecast. And then we have point difference. I notice that it's not an absolute value. That negative means that the home team, the franchise ID, lost, right? And how much they lost by. Okay, so we're looking at all of this and giving us a good Celtics. Sorry, I'm getting some pro tips that they are the Celtics, not the Celtics. Sorry, every Celtics fan out there. Thanks. Okay, so we are framing this in terms of the franchise ID. If you want to go deeper into the data, we've actually linked it up at the top, and you get what each one of these variables means. This is also really important information. And whenever you're working with a data set, your first step should be the documentation. Okay, cool. So we're looking at the first 5 tables or first 5 rows. Everything kind of checks out. Looks good to me. Let's get started. All right. I am coming to this most interested in the points. I'm like, okay, all this stuff is really interesting, but let's get down to what really matters. The points. Also, I'm based in New York. we're going to compare the nicks and the nets. So we're going to filter for each one of those. You don't want to see me make a bunch of typos, so I have pre-written my code. Let me break this down for you. I'm going to make that larger so that you can see a little bit easier. Okay, so I made a new variable. So I've made a whole new data frame. And I'm going to use the 2010 data, and I'm going to filter by where the franchise ID is equal to the nicks. Here I have the same data frame again, and I'm going to filter the franchise ID is equal to the nets. Okay, so I've said for my nicks data frame, I want only where the nicks are. For my nets data frame, only where it's the nets. You notice again that we're calling this entire data frame. So what this part says is give me the entire data frame where the data frame is filtered on the nicks. And this says give me the entire data frame where the data frame is filtered by the nets. This says now give me only the points column. Okay, so what that means is that I've filtered my entire big data frame, right? I've cut off a bunch of rows where it's like the Celtics and other teams. And now by using this piece of code, I'm cutting off the rest of the columns so that I'm only getting nicks points and I'm only getting nets points. Okay. What this looks like is just one column. It's called a series of points for the nicks, and it's in the same order and, you know, nicely organized, but we're filtering just for rows where it's the nicks and only the points column. All right, so we're going to run that and nothing's going to happen because we didn't say to print anything. So we just run it and you'll see there's no new output anywhere. Okay, I'm going to check that off and go to my next. Okay, so the next thing I'm like, okay, what do I want to know? Well, I'm going to start with what is the average difference between these two teams. That seems like a great place to start. So I'm just going to say, I'm going to calculate the mean of the nicks points. You see that part about the typos? I already got myself typos, and the nets points, right? So I want to find the simple average of the nicks and the simple average of the nets. And I'm going to subtract them from each other. And then I'm going to print out the difference. Let's see what happens. Okay, now it looks like the difference between the nicks and the nets is about 9.73 points. Now, even if you are not a basketball fan, if you come here and you look at the number of points, you're looking like, oh, okay, so basketball games, the points are around 100, give or take. That seems pretty reasonable. You know, you could have these games that have only 59, and I'm sure you could have a game with 0, but 100 seems about average-ish, 90-ish. So when we see something that's about 10, we're like, that's about 10% difference. That seems like it might be meaningful. That seems like it's worth a deeper investigation. So I've calculated the points and I don't know if they're associated, but since it's not 0, I think it's definitely worth investigating to figure out if these might be associated. Okay, so I'm going to click this one off. All right, let's keep going. So we can all recognize that comparing the means doesn't actually tell us as much as we might want it to, right? We want to do something a little bit more sophisticated. Okay, so we want to look at the distributions to see, is it just that one game, the one team scored so many more points, or is this a trend for these two teams? Let's look at this code and then talk about what that means. Okay. So we're going to make a plot and we're going to make a histogram, right? So we want to plot a numeric variable and we want to see how often it occurred. So we want to use a histogram rather than a bar chart. We don't want to use a bar chart because that's for categorical variables. If you're curious about that, please check out some of our data visualization content where we go a little bit deeper into that. Okay. I want to have a legend. I want to have a title and I want it to show up. Quirky thing about Matplotlib is that you have to tell it to show yourself in order to get it to show up. Okay, so we are going to use the Matplotlib library. We're going to make a histogram. We want to make our first histogram to be about the NICs, right? And our alpha is our transparency. So like how see-through are the bars going to be? And we've set our alpha to 0.8. So not completely transparent, but you can see them lined up enough so that you can see the two plots on top of each other. Normed is true, which we don't need to go into that too much. It just means that like the curve has been normalized. And the label for this one is the NICs. For the next one, I'm going to do the exact same thing with the nets. Okay. And I'm going to say, give me a legend, give me a title, and show yourself. So I will save that. And then it'll output a plot. And then we can see that the two distributions are actually, they look like there might be an association between the team and the number of points. How can I tell that? Well, if there was some really huge outlier, and this is a bit of an outlier, but it's not like really crazy or anything. It's not like, oh, you know, a super tall. It's an outlier, but it's not too extreme. We see that for the nets, the vast majority of their points are actually on the lower end than the vast majority of the points for the NICs. This lack of overlap here in the higher end and this lack of overlap here in the lower end for the NICs and the nets respectively indicates to us that there might actually be some sort of an association. What that means is that there might be a relationship between the team and the number of points scored. I know it sounds a little crazy to say it like that. Like, I'm just going to be honest. I know that sounds a little crazy, but that is what we are trying to say. We're just saying, oh, is this worth investigating? This distribution tells me that, that it's worth investigating. Okay, so I'm going to click that off. Oh. Okay, so now let's compare 2010 to 2014. So we're going to use the exact same steps that we used for 2010. We're just going to do them again for 2014, and I'll talk through them pretty quickly. So we're going to filter our data frames for the NICs 2014, where we have where the franchise is the NICs, the entire data frame, and then filter it for just the points column. So we've cut off our rows to only be the NICs, and we've specified only the points column. We've done the same thing here, where we've taken the entire data frame, looked for just the nets, and then returned only the points column. I'm going to calculate the difference of the means, and then print that. And then I'm going to show the difference of the histograms and plot the relative distributions. Okay, so there is one more piece of code here that I need to talk about. So we have this PLT CLF, okay, which means that we need to clear the plot out of the most recent presentation. It really depends what Python interpreter you're using, whether you're going to need to do that or not. But if you're finding that your plots are just layering on top of each other, call plot CLF, which I think stands for clear the field, I always forget what that stands for, sorry. But it clears the page so that the next plot can come up. Okay. So I'm going to save this and we're going to see what we get. All right, so we have our two data frames again. We have our 2010 season that we already investigated, and we have our 2014 season. Well, that is quite interesting. It looks like the nets were really scoring in this 105 range a lot. That is, very clear that they were not scoring 100 to 105. They were scoring 105 to 110, like all the time. That's kind of interesting. And I'm like, why are these two numbers the same? That would be a small typo on my part. That's because I printed the 2014 rather than the 2010. Note about copying your code. Okay, that makes more sense. So our 2010 that we already looked at in 2014. When I compare the means, I get a much closer result, right? What this tells me is a few things. Number one, that the nicks and the nets were way better matched in 2014 than in 2010, right? Because the difference in their mean scores is much, much smaller. That is also borne out in the shape of this histogram as well. I see that there's not a ton of like missing overlap, like the overlap here was split into these two halves. Rather, you see something pretty similar. There's this peak here between 105 to 110, but overall, there's far less overlap or far more overlap. And the overlap or the lack of overlap isn't clustered on one end or another for either team. Rather, it's kind of distributed throughout. So this tells us that in 2014, there might not have been as much of an association. This is less interesting if you're looking for an association than that first plot for 2010 is. Okay, cool. So if you have any questions about any of that, please drop them into the chat. The next thing that we are going to do is move on to, checking the questions here. Cool. Okay. The next thing we're going to do is focus on the 2010 data. And we're going to go a little bit deeper into these associations. Okay. So we are going to look at the relationship between franchise and points scored per game, right? So we're going to generate side-by-side box plots well, let's take a look at them. Okay, so first I'm going to clear my plot. And then I'm going to look at box plots from 2010. Now this time, rather than just focusing on the nicks and the nets, I'm going to look at everybody who's in the data set, all 5 teams that we selected at the beginning, okay? So why do you look at a box plot? It's easier to talk about a box plot if you're looking at one. Okay, so box plots tell us some really interesting things. They tell us what the outliers are, what the range of the majority of the data is, and where the mean of the data is. You get box plots from the Seaborn library. Okay, so Seaborn is another plotting library. A lot of people think that it makes plots that are much prettier than Matplotlib. I leave that up to you to determine. But we're going to say, hey, give me a box plot this time. We're going to say the data is our NBA 2010. Remember, we filtered the data for only the year 2010 up at the very beginning. On the x-axis, so down here, we want franchise ID, right? Because these are each of our categories. We have 5 categories, and the franchise ID is the 5 categories. We have the Celtics, Knicks, Nets, Thunder, and Spurs. On the y-axis is the number of points. So we're looking at how many points they had for each game, right? This is telling us the mean. This box is telling us 1 quartile above, 1 quartile below. And the range is telling us where the majority of the data is. Okay. So if we are looking at this, if something is associated, we expect there to be a lot of overlap between our plots. So the Thunders and the Spurs, their points per game are probably associated, right? They're probably closely related to each other. The Nets, on the other hand, don't seem to be associated with anybody. Their box here doesn't overlap quite as much as the other boxes do. So we can look at these pairs of teams, you know, the Thunders and the Spurs are probably pretty closely matched, and we could probably go deeper into the data and look more specifically at the Thunders and the Spurs. But we're going to keep going with the Knicks and the Nets. Okay. So now we're going to actually analyze the relationship between these categorical variables. So we have a question. Our question is, do teams tend to win more games at home compared to away, right? So home versus away is a categorical variable. Pause. What's the difference between a categorical and a numerical variable? Categorical variables are things that are, you put them into categories. Win, loss, draw, those are categories. There's no number associated. Celtics, Knicks, Nets, Thunder, Spurs, no numbers associated with them. They're categorical. So it's a category or a bin or a bucket. They aren't totally like, there's not a one-to-one parity with numbers, because you can have first place, second place, third place. That's a categorical variable too. So place in a race is also a category, even though we use a number to represent it. Good example. If someone were to go to the Olympics, say Simone Biles, and win first place and third place, it is not the same as winning 2 second places. She did not average silver medals, right? She got a gold medal and a bronze medal. That's how you can tell that place in a race is a categorical variable, even though it uses numbers, okay? So when we're looking for associations, we have to treat categorical variables and quantitative variables differently from each other. We use different tests, okay? Let's dive in. All right, so we want to know if teams tend to win more games at home compared to away, right? So the variable game result indicates whether a team won, lost, or drew. The variable game location indicates whether a team was playing at home or away, right? Data scientists like to use contingency tables, which just means like a box, a table of like all of these results. We're going to look at what that looks like. We're going to look at a contingency table of game result and game location. Okay, so let's look at the code to get us there. In the Pandas library, a contingency table is called a crosstab. We are going to create a crosstab. We are going to have game result on the x-axis and game location on the y-axis. So we're calling from the data frame the game result column and the game location column. Okay, let's look at what that looks like. Okay, I'll print this. All right, so I have losses and wins away and home. So there were 133 away losses by all 5 of these teams. So when they were away, they lost 133 times. When they were home, they lost 105 times. When they were away, they won 92 times. And when they were home, they won 120 times.